Welcome to this video on the topic of Year 8 Mathematics, Algebraic Division. In this lesson you will learn how to simplify algebraic statements containing division. Algebraic division may be evaluated by firstly representing the division as a fraction, listing the variables in expanded form and cancelling like common variables across numerator and denominator one for one, and finally dividing the coefficients. Consider we have 10x cubed divided by 5x squared. We know this is a division because we see the division symbol. Now to be able to evaluate this, we can translate this into a fraction. This is going to become, upstairs we have 10x cubed and downstairs we have 5x squared. Now, to simplify this, what we're going to do is we're going to identify our coefficients and write them on a fraction to the left. So that way, to the fraction on the right, we can just have our variables. Now, upstairs we have x cubed and x squared, but what we want to do is we want to write these in expanded form. So rather than x cubed, we're going to write x, 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 and rather than x squared, we're just going to write x, x. Now, to compute this, for the variables, we're going to cancel them out, numerator to denominator, one for like variables. So if I cancel 1x here, I'm going to get rid of 1x there. 1x here, that means 1x there. So for as many x's that I cancel downstairs, I'm going to cancel as many upstairs. For the coefficients on the left, I'm just going to treat that like division and say 10 divided by 5 is just 2. For the right, our variables, we have one remaining x. So what I'm going to do is I'm going to write one remaining x like so. So the rule for this is, for the variables, write in expanded form and cancel out like for like. For the coefficients, we just divide. Okay, let's put this theory to use. We have 12x divided by 3. Starting off, we're going to gather our coefficients and we're going to write them on the left. Then for our variables, we're going to write them on the right. Now notice that I've tried to write this as a fraction, but I don't have any variables over here, so that means there are no variables to put in the denominator. Because of this, we can delete the fractional line, which we call the vinculum. Okay, when my screen stops jumping around, let's finish this. 12 divided by 3 is just 4, and we have x left over. So the simplified version of 12x divided by 3 is just 4x. Alright, next one. Negative 20y divided by 5. Gathering the coefficients, we have negative 20 and we have 5. For the variables, we have just y. Remember, there is no variable in the division, so we can get rid of the vinculum. Next point of interest, we have a negative on the 20. When writing fractions, it's not useful to have the negatives either upstairs or downstairs. Rather, you're going to find it's easier to have them out front, so when we write these as a fraction, just write them out front. Next, you have a negative, you have 20 divided by 5, which is 4, and then you have a y. So the answer is negative 4y. Alright, let's look at something a little bit different. Example 2. We want to simplify the following algebraic divisions. We have x to the 5 divided by negative x cubed. Notice that we don't have any coefficients here. Because of this, there are no coefficients to gather. Instead, all we're going to do is focus on the variables, x to the 5, negative x to the 3. Remember, we don't like having negatives either in the numerator nor denominator, so what we can do is we can move them out front. Secondly, we don't really see much purpose in writing these in the compact form, so instead we're going to move them into expanded form. So x to the 5 becomes 5x's, x to the 3 becomes 3x's. Final step, we cancel 1 for 1. This x goes, so this one goes. This one goes, and this one goes. This one's gone, so that one's gone. Left over we have a negative, and then in the numerator we have 2 x's, so we get x squared. B. Negative 12b to the 5 minus 3b squared. Dealing with this, we're going to gather our coefficients and we're going to write them as a fraction. We have 2 negatives that are out front. This becomes a positive and we don't need to write that, so we just leave it as 12 over 3. Moving along our variables, we have 5b's and then we have 2b's. Cancelling out and then dividing. 12 divided by 3 is 4. We have b's and there are 3 of them. Thus the answer is 4b cubed. Okay, something even trickier. We have 14a to the power of 5 b squared divided by 10ab. We want to simplify this. Firstly, I'm going to gather my coefficients, 14 and 10. And then, I'm going to perform the next step, but across 2 lines. Rather than writing expanded form, I'm going to keep these in simplified form. So on the next step, I'm going to write these in expanded form. Okay, now, before we get to there, have a look at your coefficients, 14 and 10. If we try and divide 14 by 10, we're not going to get a whole number, we're going to get 1.4. Now in some instances this is fine, but based on the math we're doing at the moment, it's better to keep these in fractional form. We want to avoid decimals where possible. Now to get around not being using decimals, and to have this in its simplified form, we can employ the use of something called a prime factor chart. A prime factor chart tells you all the numbers and the prime factors that go into each number. So you can see 0 and 1, they're neither prime nor composite, they're just whatever they want to be. But then you've got 2, 3, 5, 7, 11, 13 and so on. These are the prime numbers. These numbers make up all the composite numbers. Your composite numbers are 4, 6, 8, 9, 10, 12, 14, 15 and so on. So we can see the number 4 is composed of the product of 2 and 2. 6 is the product of 2 and 3. 10 is the product of 2 and 5. 14 is 2 and 7. And then you can get some really big numbers, so say 56, which is the product of 2, 2, 2 and 7. What we're going to do is we're going to represent 14 and 10 as the product of their prime factors. So 10 is 2 and 5. 14 is 2 and 7. Next, I'm going to write a to the power of 5b squared in expanded form. And now I'm going to start cancelling. Have a look at the coefficients on the left. We have the 2 upstairs and downstairs. Because this features both up and down, we can cancel it out. 7 and 5 have to stay. Moving across to the variables, we have an a downstairs and upstairs, and a b downstairs and a b upstairs. So rewriting this, we get 7 over 5, and then upstairs we have a to the power of 1, 2, 3, 4, b. Now this is completely simplified, but a nicer way to write this is all as a singles fraction. So we can go 5 downstairs, 7 a to the power of 4, b upstairs. And here is your most simplified form. So the takeaway here is when we are working with composites that can't divide into one another equally, we just leave it as a fraction. We can find the simplest form of the fraction with the help of a prime factor chart. Alright, next one. 15x to the 4, y to the 3 divided by 6xy. Start off by gathering your coefficients and moving them to the left. Next, we're going to get our variables, x to the 4, y to the 3. X, y. Okay. 15 and 6, that doesn't go evenly. So what I'm going to do is I'm going to use my prime factor chart. 15 is 3 and 5, 6 is 2 and 3. Okay, and then I've written my variables in expanded form. Having a look at the cancel out here, I've got a 3 upstairs and a 3 downstairs, so they're going to go, and then the 5 and the 2, they're just going to stay. So I get 5 over 2. Next, I have the cancel out of 1x and a singular y. So I'm going to get x to the power of 3, y squared. Hence, my simplified form is 2 downstairs, 5x cubed y squared. Okay, moving along. We have 36u cubed v squared divided by 9u squared. We're going to simplify this. Moving my coefficients to the left, fractions to the right, or variables to the right. Okay. Notice that 36 divided by 9 is pretty straightforward, we can just say 4. But then on the right over here, we have so many variables. If I write all of these out, then it becomes quite long. For example, looking at above in example 3b, we had lots of variables to write this in expanded form. When we look at this, we knew that we have x to the 4, y to the 3, and we're just taking away a singular x, a singular y. We can predict that if we have x to the 4 and we're dividing it by x, we know that's going to turn into x to the 3, and when we have y to the 3 divided by y, we just reduce that 3 to a 2. So rather than doing the cancel out here, what we're able to do is we can do a subtraction instead. So let's have a look. We have 36 over 9, which is 4. Then we're going to get y, we're going to get u's, and we're going to get v's. But one way to think about it is we had 3 u's and then we're decreasing it by 2, and then we're going to get 2 v's. So when we put this together, we get u to the power of 1 v squared, and we don't need to write a 1, so we can just leave it as u. So the takeaway here is that you don't have to write these in expanded form when you're proficient at this. Instead, you can just do a subtraction, and that speeds the process up. Once more, I gather my coefficients, and then I gather my variables. I do the fast division. This is going to become a positive, so we're going to get 9. I'm going to get A, 3, take 2, B, nothing to do with the B, and then C, 2, take 1. Finishing this off, I get A to the 1, B, C. Don't need the 1, so therefore my answer is 9ABC. So notice that the division has become quicker.